Good day, everyone. My name is Oliver White, the guy from your email inbox, and your host for today's webinar with Jamie Allen, Scala expert, author, and karaoke master. While I introduce today's session, I'd like to see who out there is using what in our audience, so I'm going to launch a quick poll. It'll fill your screen for about a minute or so. It's asking, are you currently using Reactive Platform 15 version 9? If you've never heard of that before, then the answer should be relatively simple. Today, Jamie will review Typesafe Reactive Platform, or RP as we call it, which has recently been given quite an overhaul, focusing mainly on fault tolerance, or even further than that, resilience, and representing a more cohesive approach to building and deploying reactive enterprise systems. So today we'll discuss Typesafe Monitoring 1.0, a newly instrumented version of RP to visualize and drill down into Akka actor metrics, which is with our first Takipi. We'll also discuss Akka Split Brain Resolver, a new module for handling network partitions in production systems found only in RP, as well as Typesafe Conductor, which has a new demo app and a developer sandbox to experiment around in. Don't worry, at the end we'll show you how to get started with these. I will shut the poll off, and hopefully we can go back to Jamie's screen. That worked well. If you have any questions, please do put them in the Questions tab of the GoToWebinar control panel. And as always, a big shout out goes to our happy subscribers, 91.54% of whom report extreme happiness with their Typesafe relationship. If you want to know more about that, you can email oliver@typesafe.com to get a hold of me directly. Okay, that's enough out of me. Let's hand it over to Jamie Allen.
Thanks, Oliver. Can everybody hear me okay? Thank you. Thank you very much. Welcome, everybody. I'm really excited to be here. In this particular presentation, what we'll be talking a lot about is how to use the reactive platform to make your applications even more fault tolerant, even more able to be elastic to the kinds of load that most companies are seeing in today's world. And a lot of that has to do with the fact that people are deploying applications in ways that 10 years ago we weren't even thinking about. Before, we had people who were just interacting with us through their browser or through various kinds of specialized devices, like maybe an iPod or something like that. But now we have all kinds of devices which are talking back to our systems, and every business has to be cognizant of how those experiences are going to be felt by their customers. So let's delve into it here. The Typesafe Reactive Platform is really built around 6 components, if you will, currently anyway. And it also has a lot to do with the idea that people are going to build services that are much more targeted toward delivering specific functionality instead of being monolithic. This comes with some operations overhead, some of which we try to address through the reactive platform, but gives you tremendous benefits in your ability to be quickly able to deal with the world around you. The microservices approach involves you defining how you are going to split apart the various parts of your system that are going to be required to serve answers to various constituents. That could be other systems, it could be users, it could be just about anything. An example I like to give is that at one point I was working for a large cable company in the United States, and one of the things we were doing was every time somebody was trying to watch TV on demand, they would use their remote to click and see what shows they could watch or what movies they could watch. And every one of those clicks on the remote control was actually a web service call back to a data center. And then we'd figure out, based upon some call to a monolithic Oracle database, whether or not they had the entitlements to watch that kind of show. That overwhelmed the database, and that didn't make for a very good experience for people trying to watch on-demand content. So especially whenever everybody was trying to watch at the same time, usually after dinner, we'd have this massive burst of traffic, and we wouldn't be able to handle it in a clean and fast way. So by splitting out the entitlements, the way people get the information about what they can watch and when, we were able to, quickly provide people with information about what, content they could watch. So splitting out functionality, but also when you're thinking about microservices, you also have to think about the deployment footprint, because you can say, well, hey, I want every one of these microservices to deploy independently, but you should also think about which ones matter to deploy independently. Maybe it's worth deploying a couple of them together on a couple of boxes. And how are you going to leverage that? So that gets into orchestration. So we are going to talk in this particular presentation about how we manage orchestration and how we deal with fault tolerance as microservices and the infrastructure on which they live are changing, such as, network splits, or whenever a machine dies because a disk goes down. I believe Google has a metric out there that says roughly 20 out of 1,000 machines will be down at any given point in time inside of a data center. And if you think about the number of machines that are available inside of a single data center, I mean, that could be in the hundreds or thousands number. So that's a large number of machines that are currently under service and not available to your platform, and they can go at any point in time. It's not like they wait until they're done, handling a particular request before they say, okay, I got to shut down, my disk just died. That's not how things work. So let's talk a little bit about the reactive platform and what it means, and then we'll do a deep dive into improving the fault tolerance, and that's really about resilience as far as reactiveness goes. And then next steps, how do you get started? So who am I? I'm the Senior Director of Global Services at Typesafe. That means my primary job is to make people successful with our platform. And Typesafe is not a consulting firm. We're not out there looking to sell you, 1 million hours of consulting hours so that, we can make a ton of money or something like that. We really focus on product development. But that doesn't mean that we don't have customers who come to us and say, hey, I need some help with something. We'd like to do this, but we're really not sure how to approach it. And in that case, my job is to make sure that they have the right people at their disposal to make sure that they can do that. I'm the author of the book Effective Akka, and I'm a co-author of Reactive Design Patterns with Roland Kuhn, the current head of the Akka team. That book has 14 chapters completed at this point, though the 14th is only partially done right now. And that's out of 16, so we're really close to finishing the book. I hope to have it out by the end of the year, or possibly early Q1. So now when we talk about the way businesses have to evolve, Netflix is a really good example. And a lot of people look at Netflix and say, well, that's, this new hot tech company out there. They've been, only around for a short period of time, but they really haven't. They've been around for a while at this point, and they've had to pivot their business model. They used to send you DVDs through the mail, and that was an experience that could take a couple days. Whenever you said you wanted to watch something, you'd receive a DVD and then you had to return it, or who knows what. I actually never used it myself. But now it's all content delivered through the internet. And you can see the impact of how that change really transformed their business and destroyed the businesses of their competitors. At the time of I think early 2005 or something like that, Blockbuster had a chance to buy Netflix for something like $50 million, and they didn't do it. And in 2010, Blockbuster was bankrupt because of Netflix. And Netflix has continued to grow as they built this streaming business. And the internet has really enabled that. But being reactive to their users has been incredibly important as well. In 2011 or 2012, I remember a massive outage due to AWS being down that caused them to be completely down during one of the hottest times of year, during the holiday season. And that was a real big learning experience for Netflix, to a point where they started building infrastructure to take themselves down in production to find out whether or not they could withstand various hits, whether they lost a node or whether they lost an availability zone or a whole data center. Would they still be able to provide streaming content to their customers? Another example in this exact same arena is a company called Major League Baseball Advanced Media. A lot of people look at this sort of content platform and say, oh, that's just another sport that Americans have created where we define ourselves as the world champions and stuff like that. But Major League Baseball Advanced Media is a massive and growing concern, because it's not just about Major League Baseball. They are the people who broadcast the Olympics. They are the people who broadcast the World Cup on the international stage, streaming across the world. So while they were created around Major League Baseball, they quickly became the premier platform for delivering ad hoc content, and other companies have started to use them for delivering their content as well. An example of this is HBO. Here's an organization who has had a very traditional business model where they were going to deliver over cable. Well, now they can deliver directly to you without you having to have a subscription with the cable company. And they do that through Major League Baseball Advanced Media. So streaming video is transforming businesses around the world. GE is another company that has really had to transform. Every one of the devices that they sell, whether it's a coffee maker or a dishwasher or a refrigerator, is now in contact with their business on the back end and talking to them about whether or not they have diagnostic issues or any kind of maintenance problems. This is now very important to GE that they can withstand all of this traffic coming from all of these devices. And they use our platform to help them do that. So large companies rely on groups like Gartner Group to provide them with analysis of where the tech landscape is going in the future. And at this point, groups like Gartner are beginning to tell their customers that business is shifting, and they need to be able to move along with this shift in order to stay current. Otherwise, they themselves are going to fall behind. We see this with a lot of companies that might surprise you. They've been using legacy technologies for a long time, and now they're to the point where the cost that's associated with leveraging these expensive platforms that have existed for a long time is no longer viable for them. They need to shift in order to save costs, but they also need to shift in order to scale, because those expensive platforms simply don't do it for them anymore. And this is the reactive manifesto as it was defined in 2013 and has since been refined. It's now at version 2.0. The community has really rallied around this, and it's come from interesting places such as the high-frequency trading world, which was a real surprise to me. But the way that that's changed is it's helped us evolve over time, and it's helped us really think about how reactive matters. At the bottom of this, you see this concept of message-driven. I wrote a blog post about this about a month ago or so, talking about how we need to be asynchronous and non-blocking. And if we have a message-driven architecture, we are doing that almost implicitly. Think about if you put a message into MQ series or RabbitMQ or something along those lines. You put the message in there. You have no idea when that message will be handled, and you also have no idea who will handle it. Somebody on the other end is subscribing to consume that message at some point in time, and it's not in your control anymore. Well, if you take that a step further, you realize that begins to drive your elasticity. If you have n number of nodes out there and you have all kinds of traffic coming through, when you're pushing these messages into the queue, somebody out there can consume them. And you could have more and more of these nodes out there that can do that work. But to be truly elastic, you also have to think about how you're going to minimize the contention points between each one of these nodes. If there's coordination between nodes saying, well, I've handled this message and I've gotten through 3 of the 5 steps I need to do, but I can't do the rest until something else happens, well, that's really going to affect your performance. The more linear scalability comes from being able to say, I do not have contention points between pipelines of work that need to be performed. If I'm independent, I can scale up nodes as I need, and I don't have to worry that they're going to need to talk to one another to figure out what they're doing. This kind of elasticity is very important for scale, but it also gives you the ability to scale back down whenever you don't have a large number of messages. The key thing to think about when you're talking about elasticity is you want to scale up fast, but you want to scale down slowly. And then if you don't care which one of your machines is handling these messages, that also helps support resilience. Because now if a machine goes down handling a message because a drive failed or there was an out-of-memory error inside of the JVM or who knows what, well, another message can always take up that, or another machine can take up that message later because it was never acknowledged, right? So from message-driven application semantics, you get elasticity, you get resilience, and you get responsiveness as a result of this. Even if you're at a case where you've said, I've got 10 boxes out here and I've scaled out to use all of them, well, okay, now I've got, all this extra load that's coming through. You can now use something like a PaaS, a platform as a service, to start scaling out even beyond your own infrastructure. And in doing so, while you may have increased the latency somewhat of the work being performed outside of your own infrastructure, at least you're being responsive as opposed to giving somebody something like a 404. So message-driven is really the key, the cornerstone to being reactive. And in 2013, whenever the reactive manifesto was penned, we sort of did it on the slide. We said it, we put it out there, and we wanted to see what the world thought of it. And in time, we've seen a lot of organizations out there, particularly companies who have been traditionally competitors in our space, who are big believers in what we're doing. You see this around this entire landscape, from Pivotal, you see it from Red Hat, you see it from companies who are actually partnering with us, such as IBM. IBM has entered into a large partnership agreement where we are now working with them directly to help them scale the world in data science using Spark. So just last week we released a bunch of videos explaining to people how to use Scala on bigdatauniversity.com. And IBM is going to be working with us to release more and more videos about how to leverage Spark and how to use notebooks to ask questions of your data live in memory and find out what's happening in your business right now. So this is really exciting to see the industry moving in this way. And then we also worked with some of our traditional competitors to define reactive streams, which is a way of saying that if I'm going to have all this data coming at me, it's a constant flow, I don't know when it's ever going to be done or if it ever will be done, I'm going to now say, well, I need to be able to withstand tremendous amounts of this data coming at me, and I need to be able to provide back pressure back to whomever it is that is providing it to me. And this can go all the way back out over TCP. So back pressure can be in your system all the way out to the initial producers of where the traffic is coming from. And we've worked with Pivotal, we've worked with Red Hat, we've worked with the people at Netflix who were creating RxJava, Twitter was involved, and now you see in JDK 9 an implementation that's going to come in the Java util concurrent package. So this is super exciting to see the world adopting this viewpoint that back pressure is so critical to making reactive systems. So it's been pretty gratifying to work at Typesafe. I've been here for, goodness, 3.5 years now, and I've worked a lot with customers over that time, and most of them are just over the moon with the way that they're able to build software that now exceeds their expectations for what they were able to do, and the number of resources they were using, and the amount of code they had to write, and the amount of performance they got out of it, whether you were talking about latency or throughput or footprint. And as a matter of fact, I literally just got off a call with people about an hour ago where we were talking about how they had just put together a proof of concept using reactive streams. And they were using 75% less hardware, and they were getting 6.5 times more performance. That's just fantastic. And they hadn't even started optimizing the system yet, and they were super excited. So this is just really exciting to be a part of, right? So let's talk about the reactive platform itself and find out a little bit more about how the commercial products that come with the reactive platform from Typesafe can help you build these kinds of systems. And again, back to this view of all the things that are provided from Typesafe, there is the open source projects, and there always will be. And our goal as an organization is to never make a different build of the bits of the open source projects that differ somehow in the commercial products. What we're doing is providing you with extra functionality above and beyond, but we're not going to change the open source projects because we're open source, zealots in a lot of ways. We don't want to not be an open source company. We want our projects to always continue to evolve in the open space and be part of the community. So that's how we're operating going forward. You can see these core projects here, including Play, Akka, and while we're huge fans of Scala for obvious reasons, we've come to accept that Java is a really big part of our platform. And that really drives adoption, because if you imagine, there's a lot of organizations out there who say, you know what, I want all of these really great things in my system. I want to be able to say that my system is reactive, but in going asynchronous, in being non-blocking, in having people do these message-driven systems, I've got to deal with a lot of DevOps. I've got to deal with a lot of new concepts. Do I really want to learn a new language as well? And we see that as something that's almost, something that companies are going to do over time, right? So we support Java. You can use Akka and play fully from Java. And we will always support that as much as we can. But the real driver towards Scala adoption right now is Spark. And a lot of that has to do with the fact that Java is supported in Spark. You can write a job and deploy a jar to be executed through a Spark cluster, but you don't get the interactive experience of being able to talk to your data live in memory that you do with Scala and Python, for that matter, or R or SQL. And that's a real limiting factor for Java. And as a result, people were saying, you know what, while we weren't necessarily ready to make the push on Scala before, now we are, because we really want to leverage the power of Spark. And so a lot of people are coming to Scala as a result of that. And it's almost as though at Typesafe we don't feel like we have to push Scala anymore. Scala is now pushing itself largely because of Spark. And that's driving the adoption of Scala using Akka and Play as well, because once people start using it for Spark, they start seeing what they can do with it as a data-centric language, as opposed to a language which treats data like second-class citizen. So that's been really gratifying for us. Now, to talk about the reactive platform, we'll work our way around the wheel a little bit here. There's application monitoring. And, to be truthful, this is something that at Typesafe we've struggled with for a couple of years. When we first came out as a company, one of the first products that we put out there was something called Typesafe Console. And it's even reflected at the end of my book, because at the time that was supposedly the way that we were going to monitor Akka-based applications. What we found out was that it doesn't make sense to try and monitor everything in a massive system. And a lot of that has to do not so much with the performance hit, because you can use various sampling methods to limit that. It has to do with just the overwhelming amount of data points that you have to collect. And so we were able to collect the data, but then when we tried to show it in a meaningful way, we practically melted browsers. It just didn't work particularly well. So what we found out was, hey, we're really good at building these kind of back-end systems. We're not particularly good at doing the front ends. And so what we've decided to do instead was, let's make application monitoring part of the reactive platform. We can expose the metrics, and then you can consume them in a way that makes sense for you. We have a partner called Takipi right now, and in version 1.0 of the application monitoring, it is the only front end that you can use. And Takipi is a pretty cool product, because not only does it show you the traditional metrics that you really want to see in actor-based systems, such as, how big are my mailboxes and are they draining, right? Or how much time does it take to get a message into a mailbox at a time when the message is actually handled, that latency of message handling. Those are the key metrics you really want to be paying attention to at an actor level and also at a thread pool level. And Takipi gives you that, but not only that, Takipi also gives you the ability to drill into source code and see the exact points where errors are occurring inside of your system. That's a really unique feature. But in the next quarter, what we're going to be doing is exposing an SPI where you yourself can tap in and integrate with something like Grafana or StatsD or Hystrix or whatever front end you want to bolt in as an event stream, and start collecting that information and showing it yourselves. So application monitoring for now, it's free as part of the commercial platform. You don't have to pay some sort of extra thing above the commercial platform cost of Typesafe's reactive platform. But you soon also could use Takipi as a front end, or you could use your own front ends however you choose to consume this data. So this is going to be really important for understanding reactive systems. And one thing I'd like to point out here is that while we're doing this, we're also improving the tooling around how you develop these sort of systems. And application monitoring is great whenever you're talking about how do I see how well my system is running at in production. But if I'm sitting there and trying to develop a system and trying to understand the problems that are happening, I need debugging tools. And there aren't a lot of tools out there for anybody working in an asynchronous platform. There simply aren't. It doesn't matter what platform you're using. If you're in Go, you might have the race condition checker, but it doesn't allow you to walk multiple threaded applications in debug mode. You can't do that with core.async enclosure. You can't do that in Node.js. How are people going to be able to walk a message send or walk a event loop, and say, well, here's the next thing that would happen if I maintained that thread? And that doesn't happen in other platforms. We finally have that. It's in Scala IDE version 4.2 now. It's called Async Debugger. And on my GitHub page, github.com, Jamie-Allen, you'll see an async debugger demo. Show you how to use this so that you can use this to walk message sends, to see where messages came from, and see the state whenever a message was sent. It's a really big deal to increase the tooling for people to be successful writing these kinds of applications. There's also system orchestration. And a lot of what's happening in the DevOps space right now is awfully confusing because we have to think about the various layers that comprise our deployment footprint, what we're going to use and where. Let's just start, down at the bottom. We have a whole bunch of machines, and maybe they're being coordinated through, a hypervisor or something like that, like a VMware. But imagine you want to treat all of those machines as a single organic unit, as opposed to a bunch of disparate ones. And by that I mean you use a tool like Mesos. You're going to say, instead of having 100 machines, each with 24 cores and a terabyte of RAM, well, you're going to look at this as though you have 2,400 cores and 100 terabytes of RAM, all in one. And Mesos is going to be the one who's spitting the work out there and provisioning, if you will, right? But that doesn't help you at an application level. Now at the application level, you've got to figure out, well, I want to deploy a service, like that entitlement service I was talking about from that cable company from before. And I want to keep 3 of them up and running at all times, and maybe a 4th as a cold backup, just sitting ready to go if I need it. Well, okay, great. How am I going to orchestrate that? And you see tools that are coming around in this space that are growing now. In Typesafe, we have our own. We call it conductor. And conductor is particularly useful because it doesn't put constraints on you like some do. In Kubernetes, for example, you have to use Docker. In the JVM world, I'm not entirely convinced that Docker is a requirement in production. I see a fair number of companies using it for homogenizing the development environment and the test environment, but then when they go into production, they're not using Docker. And there are several reasons around that. Some have to do with maturity, some have to do with what exactly is it buying me whenever the JVM itself is a container. But if you don't want to use Docker, you don't have to. It's up to you. It's orthogonal to the orchestration itself as far as conductor is concerned. And then we have this idea of partition healing. And I'll get into this in a lot more detail shortly, but it's very difficult in a production environment, especially as you're increasing the number of nodes that are available to your system, to deal with the fact that sometimes networks split and nodes aren't available to one another for a period of time. And it's very difficult to figure out how you're going to manage that. How are you going to keep your application available and up and running, as opposed to everything going down and some operations person having to figure out, okay, how do I restart all this stuff? So maybe it's better to keep a part of your application up. And what choices are you going to make when you do that? Our partition healing technology is really about helping you make decisions that are best suited to each one of your deployments, so you don't have to sit there and say, I have one rule of thumb and that's the only way I go. Because every one of those choices does have trade-offs, and we'll talk about that more shortly. And then there's application availability, whether we're protecting apps against abuse like DDoSs whenever somebody hits you with a denial of service attack. How are you going to protect your front ends from people who are sitting there and just hammering your servers because who knows, maybe they don't like you for some reason, or or they don't. You can't even predict why people would make these choices. So it could be a competitor who's doing it to you. And as a result, you can protect yourself by keeping your application availability up by limiting the amount of requests that you're taking on a particular server and not allowing it to be overwhelmed. And then there's legacy integration for your application. When you have platforms that you've been using, such as databases that are expensive and you can't get rid of them because migrating off of them would be a tremendously time-consuming effort, you need to be able to use your application to talk to them right away. And then there's also the concept of message passing using technologies such as SOAP. Are you really going to write your own SOAP layer in this new platform that you're going to start leveraging? You can, in Typesafe's Reactive Platform, use Play's SOAP module rather than having to do this yourself. And then you're also getting the added benefit of not having to maintain it yourself, write it yourself, and more importantly, you know you're getting best of breed because this is evolving based upon everybody's experience using this module as opposed to only your experience and then finding out something that you just haven't come across yet. With the Typesafe Reactive Platform, you also get security alerts. You find out whenever there's any kind of incompatibilities or risks involved in the platform. And as much as we like to think that we write a really great platform that works well in all circumstances, if you look at the security space right now, you see all kinds of vulnerabilities that come from places that no one expects. Heartbleed was a really good example of this. And just I think a week or two ago, we saw that there was a problem inside of Java whenever people were deploying applications that leveraged just a certain combination of Java serialization and other libraries, like Apache Commons. All of a sudden, everybody is worried about their own security, and finding out whether or not you're affected by this is really important. So inside of Typesafe, we've had customers who have come to us and said, you know what, we did our own security audit, and we found this one little thing right here which we think is sort of worrisome. And then we immediately push that out with a fix to our customers, but also provide a notification so that you know that this is a potential vulnerability. We have our certified builds, which to me is something that's kind of important, specifically because I've worked in that space where I'm an OEM developer, right? I'm creating a product that I'm going to sell for other people. And I want to make sure that I'm not going to send something out there which has any kinds of incompatibilities or third-party library usages that could be troublesome. In Typesafe, we literally build as much of the community as we can every night. We literally are doing that to make sure that we know if we are breaking something for somebody else, if anything is going to happen out there that whenever somebody else upgrades to a new version, what is the effect on the rest of the community? We're literally telling other people who are just open source developers, hey, when you did this, it's causing this kind of problem for everybody else. And so this is really important that we are watching over this and making sure that this is working for everybody who is a reactive platform enterprise user, because you don't want to find these things out yourself, especially in production. This reduces guesswork, and it really speeds up the development of your applications as well. And then finally, there's expert support. In Typesafe, we do not have a group of people whose job it is to keep you away from our engineers. Our primary goal is to make you successful with our platform, because if you aren't, you're not going to become a customer. And so when you're asking questions from Typesafe, you are getting answers from engineers. You're getting answers from the Akka team, the Play team, the Spark team that we have. And this means that you are getting immediate knowledge transfer without that cost of having somebody sitting by your developers all the time, talking to them and coaching them. It's almost the same thing, and it's much cheaper to do. And it helps your entire team instead of just a few people. So let's move forward here. Let's focus on fault tolerance. Let's talk about resilient systems and what that means. That really gets into these top three elements here of the reactive platform: the partition healing, the application monitoring, the system orchestration. It also touches on the application availability a little bit whenever you're talking about being resilient to people who are trying to overwhelm your servers. But at a recent conference, I think DevOps or I forget which one, it was only about a month ago, Jonas Bonner, he's the creator of the Akka project and also a co-founder of Typesafe, he said, without resilience, nothing else matters. It doesn't matter how beautiful your application is or all the work that it's doing if it can't stay up, right? Nothing else matters. So it all starts and ends with resilience. And this has been a keynote of the world for a long time. If you look at the Erlang platform, which is built 30 odd years ago by Ericsson, they were thinking about how they were going to make uptime in telephony switches. How were they going to do that? They built a whole language and a whole platform in order to support a different approach. And the approach is wonderful. It works very well. Erlang has an incredible reputation for uptime. At the same time, Erlang is a dynamic language. It doesn't have the correctness built into the language before you deploy into production as far as knowing what you do when you receive a message. How well does that work? And its performance can also be a little bit slower in handling those messages because it's all interpreted. But it's still got the best reputation for uptime. And that's really impressive. And we tried to emulate a lot of the things that Joe Armstrong and the Ericsson team, Robert Verding, Francesco Cesarini, all thought leaders in this space. We've tried to emulate a lot of the things that they've come up with, but also tailor it to the JVM, where you see the tremendous platform support and all of these legacy libraries that we want to use. How do we tailor the ideals of Erlang into a platform that more people are using? So let's talk about strengthening resilience, and that comes with network partition handling, right? If you have a network partition, it's literally going to make your application say, I don't see all of the nodes that are part of my cluster. And this is really tricky. We have pre-built strategies built into Akka SBR, the split brain resolver. And they break down into something called static quorum, which is very much like the way Zookeeper handles things. We have something called keep majority, keep oldest, and keep referee. And I'm going to explain these in more detail shortly. So let's look at what network partitions look like to our operations personnel. We've got heartbeats happening between our different nodes here, right? And each one of these nodes has various applications deployed on them, but they're talking to one another, and they're making sure that they all know that each other are there. And inside of Akka, we use something called phi accrual to probabilistically determine whether or not a node is part of the cluster still. So we're constantly figuring out whether these nodes are around. But then this one node gets split off because of a network partition. And it can't see the other three. And it doesn't know what to do as a result of that. So if we sit there and we say, all right, hey, team, we lost one of our nodes. I'm going to take over that A because I can't see where that A instance of an application is anymore. What am I going to do about that? And so it moves it over here. And this is good, assuming that that first node actually went down. But it's kind of bad if that node where A was originally located was still there, but was unresponsive due to something like maybe it had a major garbage collection take place and compaction, and it was stopped the world. It just wasn't talking to anybody for a while. That's a real problem, right? This idea that we're going to try and keep nodes up with multiple representations of data at the same time, both accepting requests, is one of the trickiest things in the world, because at the end, whenever the node does somehow rejoin this cluster, how are you going to resolve the events that were handled by the one node that split off versus all the ones that were handled by the rest of the nodes? You can't. It's not easy to figure out this problem. And so in the Akka world, we came up with this split brain resolver. And the basic behavior inside of Akka is binary. If you look at the open source project, you have two choices. One is I automatically down everything whenever a network split occurs. So for example, I've got 5 nodes up, and 2 of them split off. Well, because they can't talk to each other, they all go down. That's not going to be really good for your responsiveness. But if you say to keep the auto down off and to stay up, well then your ops people have to know to turn off the 2 that split off, or the 3 that split off, whichever choice. They've got to make a choice. And that's not very easy for your team to do on the fly. So Split Brain Resolver is doing this in an automated fashion. It's going to say, well, if I have 5 nodes, how am I going to figure out which ones stay up so that I can be responsive to my users, at least some of them, right? And for the ones that went down and went away, we take them down automatically. In the static quorum, we're going to say that if I have 5 nodes, I must have 4, or I must have 2 in a quorum to stay up. In this case, on this diagram, we're saying 3 out of the 5 must be in a cluster that was split apart to stay up. And then the 2 at the bottom will go away because they'll be automatically downed. But static quorum is imposing some limitations on your system, and I'll speak to what those are very shortly. The keep majority is very similar. In this case, we have 8 nodes, and I'm not really a big fan of this particular example, but I want to make sure that I make a point, and that's why I've kept it in here. When you're dealing with clusters of nodes, it is always an excellent rule of thumb to make sure you have an odd number of nodes. And we saw this rule from the zookeeper world, right, where people were saying, well, if I had an even number of nodes and I had a network split 50-50, how would I ever know which ones to keep up? And so everybody said, well, as a rule of thumb, use an odd number of nodes. And this is a good rule of thumb in any decision-making body out there. Look at the United States Supreme Court. There are 9 justices, right? And that makes sense because very rarely, barring an abstention of a judge, you have an even split in the decision-making process. So always keep your distributed systems with an odd number of nodes. And in the case of keep majority, which is really what is a way of saying if I have 50% or more of my nodes, well, that's the one that I keep up, and the other one I take down. But again, this comes with some cost, because if you're saying, all right, well, I have a majority, what if you have 9 nodes in your cluster and they split off 33%, 33%, and 33%? That's not going to be a majority, and they're all going to go down. So this is a useful tool to have in your toolbox, but it isn't necessarily the choice you want to make. So what about if we said we had a referee node? Okay, well, a referee node could be the one that says this statically is the node that has to be part of a cluster that is going to stay up. And then if we said we had a network split and we had 5 nodes, 3 of them split off, but none of them have the referee node inside of them, and 2 of them are still sitting here off to the side, and 1 of them is the referee node. The 2 nodes are what are going to stay up, because that's where the referee node is. But the referee node being static means that, well, what if that node fails for some reason? What if that's the one that has the disk failure, or the out of memory error in the JVM or something like that? Well, then you've kind of lost your referee. So that isn't necessarily the way I like to think of my systems in most cases either. The one I like best is keep oldest. And it's a little bit more dynamic because oldest can change over time. With the oldest node, I'm saying whichever node was the first one in the cluster, that is the one that has to be in the cluster that survives, right? And it's a registrated, registrated isn't a word. It is an organized oldest node based upon consensus among all 5 inside of the cluster. They must all agree, you are the oldest node. And if somebody else has to take over oldest node because the oldest node is the one that went down due to a disk failure or something like that, well, then they all have to agree, that is the oldest node. There is a possibility, though, that oldest node may not be reassigned because it went down and a network partition took place at the same time. There is no panacea here, but there is at least a strategy that allows you to, in most cases, deal with the kinds of failures that happen just from a network split alone. So anybody who tells you that network splits are okay and we can guarantee 100% uptime with our clustering technology, well, they're making choices. Make sure you know exactly what choices they've made, because they have to follow the exact same things we're doing here. We're just allowing you to make the same choices for your application. So it's very important. Okay, so when you're using the Akka split brain resolver, we consider it a no-brainer if you're using Akka cluster and you deploy to something like AWS, a very dynamic and fluid environment. We highly recommend that you check out the documentation. If you go to akka.io/docs, you'll see the documentation for the current version of 2.4.0 of Akka, and you'll see underneath it in the HTML view, or if you do a search, split brain resolver, it will show you all the information about these different technologies and the trade-offs that you're making with each one. So now let's talk about orchestration, and this is really about our technology we call conductor. And conductor is, very much about how many instances of my application am I going to be running at any given point in time. Am I going to be running on tens, hundreds, or thousands of nodes? And this is where it gets interesting. Remember how I was saying that you should never be deploying on an even number of nodes? Companies do come to us sometimes and say, well, I want to run on 2 nodes. And we understand that. They want to minimize the impact of having a distributed system. But then you don't have that odd number for decision making, and it becomes very challenging to figure out how you deal with split brains. So we recommend that the minimum number of nodes you have is 3, not 2. And so when you're in that scenario, it's challenging for your operations team. How are you going to make sure that you have the correct number of instances of the application running on the nodes that are part of your cluster? And so that's where orchestration comes from. In this particular case, if you had 6 nodes up and running and you had various applications out there running on them, if one of the nodes goes down, we have the ability to automatically bring up the instances of the application on the remaining, on the remaining nodes. And that way you have automated cluster startup, you have dynamic service discovery, so you don't have to worry about, do I have the ability to talk between these services? Because all of the proxying is taken care of for you. And also, you can do scalable rolling updates where you have version 1 of an application and version 2 out there at the same time. Very much like the OSGI vision that was so prevalent in the previous decade. Anybody who used OSGI probably remembers that it wasn't easy to do. But this relatively is. You deploy a bundle. It's a new version of an application. You can have both of them out there and talking to one another until you can stage down the previous version because other services are still depending on the old one. And we have a lot of resilience built into conductor, where we're doing load balancing at scale and auto recovery whenever nodes and applications fail, and also advanced partition resolution, where we're doing the figuring out of what happens whenever nodes are splitting off. So it's very helpful for teams not to have to think about all of these details. It's very easy to do this. It's literally an SBT plugin. You use the plugin to say, hey, I want to generate a bundle. It's just like a phase, like compile or test or run, and then you test the bundle locally. Then you install the proper configuration and you put it into production. And you deploy the application with the proper configuration, and maybe you have some infrastructure around it. If you want something like Docker, if you want something like other technologies around it that are supportive of operations management, well, then you can use them. Conductor can handle just about anything you throw at it. For example, the ecosystem, we work with Mesosphere, we work with EC2 and AWS, Docker, Chef, Kibana, Puppet, you name it. We combine with our monitoring system, and we have a consolidated logging platform as well, using the ELK stack. So, Elasticsearch and Kibana and what is the L? I always forget this one. I forget. Nonetheless, the consolidated logging allows you to not have to worry about this yourself, so you get it all together in a single view as opposed to having to figure out, based on all these different machines, what was happening where. Without Conductor, you have to deal with your build machines, your operating system, your app server, your app's lifecycle, and you have to add the resilience yourself. How you're going to deal with load balancing and configuration, configuring which machines are talking to which, right? With Conductor, most of this is handled for you. You do have to do some configuration yourself, but it's just a matter of saying, how many instances of an application do I want out there? So we consider it a no-brainer. Using Akka cluster, deploy to AWS, use 3+ nodes, and it just works. And if you want, you can go to our website and see an interactive demo and enjoy the sandbox and play around with it and see what you think. And then application monitoring. Asynchronous development isn't easy. Anybody who tells you it is, they're lying to you. I've been doing it for, goodness, 6.5 years, and I can tell you it's been troublesome because I've had to do a lot of this work myself. There weren't tools out there to help me figure out what was going on. And traditional profiling and traditional monitoring doesn't show you what happens whenever a thread says, okay, I'm going to do something and send a message. And then it gets picked up somewhere else on another thread or on another box. You've got to figure that out all by yourself. And in a lot of respects, people just sit there and look at logs. I'm not a big fan of that. I've resorted to using JMX an awful lot to try and figure out what's happening in production. I do it on a read-only basis because I don't want to really affect my application. I don't make it so that I can introduce new state or wipe out state in production. That's always a bad idea. But I can use it to view things. And so that was always my best trick. But now with monitoring, you have the ability to figure out exactly what's going on inside of your application and see where the errors are occurring and see where the spikes in traffic are taking place. Where does your application need to scale and at what time? You can start figuring out, you know what, every day at 7 o'clock I'm seeing this happen. What is the reason for that? Is it because of some sort of traffic coming into my application? Is it happening because at 7 p.m. somehow my database was configured to do some sort of own compaction, and that means that there's tremendous latency on every message I'm handling? It's very important to figure these things out. And then also to be able to see, this is the example using Takipi, where these errors were occurring. If I see that an error is occurring inside of my application, in Akka we have tremendous capabilities to see what errors are occurring where. It's great to be able to see that in source, not just in some stack trace or something that's been printed out through the log or through the visual interface. So this allows you to delve into the actual source code and see that. So Takipi is a powerful front end for this platform. And in time, what we'd really like to see from, and this is our roadmap, if you will, we're going to see this for everything. Akka streams and data flows are all going to be covered through monitoring. Right now, they're not, but they will be shortly. And Akka streams, most people aren't using that in production just yet. It only went 1.0 about a month or two ago. So, you know, it's still a nascent technology as far as most people in the enterprise are concerned. They may be looking at it. For example, that company I mentioned earlier who saw such tremendous improvements in the footprint and the performance that they had of their application. We're going to be doing this a lot more for the play-based applications, so you'll see futures supported in Java 8. And we'll be making this available so that you're watching end-to-end applications that are built from Akka underneath, showing you their performance in various areas so that you can now make decisions in production about what's happening. So every organization wants this visibility in production. It's very important. And whenever you're doing anything asynchronous, it's difficult to find tooling that will help you. We think that our Akka-based monitoring system is the best of breed solution out there. So the world is going reactive, and we want you to be able to get started quickly and easily. We recommend that you sign up to get a license ID if you're already a Typesafe customer. We can help you set up your builds to get the proper versions of the jars down from our repositories, or set up your own local mirror. And in doing so, you will be able to try out all these features and see whether or not they're a good fit for you. You can experiment with ConductR and see if it works with your platform. You can do a demo, or you could even schedule to try it out with our salespeople. They will help you get started with it and see if this is a good fit for you. And then you can always get in touch. Please come to our website and click on the Contact Us button, and we will be back to you as quickly as we possibly can. So that's it.
All right. Thank you very much, Jamie. That was a sorry. That was quite a deep dive. I'm glad to see that some people were definitely interested. One question is about ConductR. How does it integrate with AWS in terms of launching machines, configuring pools, security groups, etc.?
I don't want to answer this myself, but I can have Oliver provide an answer to you. Oliver, do you have their contact information?
Yeah, I've written that ConductR is actually something that gets launched with your existing infrastructure tools. So if you're deploying on Amazon, if you're using Puppet, Chef, or Ansible, you deploy ConductR along with the app bundles. And
well, yeah, but there's a hook here. I think Ed is the best person to answer this question. I don't want to botch it. So
All right.
let's get back to them with an answer about this that is both correct and helpful.
Yeah, great. Another question: is it possible to monitor Akka Play applications deployed on Heroku?
Well, yes, but it's not connected in any way, shape, or form. The Akka application doesn't know it's running on Heroku, so it's providing you information about the application deployed on it. But I haven't deployed it on Heroku to see if there's any reason why it wouldn't. Most of the companies I work with, they don't tend to use Heroku, so and not because Heroku is not a good platform or something like that. I know Scott Klassen at Heroku. He's been using the Scala platform for years himself. But I don't I don't know if there's any reason why it wouldn't expose information. Like, for example, it's blocking ports or something like that that the monitoring would require to be exposed. But from a strictly technical perspective of running the application on top of it, as long as it has the ability to put the information out through a port, then there's no reason it can't work.
Mm-hmm. Alrighty. Well, I think that's all the time we have for today, folks. Again, my email address is oliver@typesafe.com. If you have any extra or more detailed questions that you'd like answered a little more privately, please do email me there, and I'll find someone to speak with you. So again, thank you very much, Jamie. Thank you very much for everyone who joined us. You'll receive an email with the recording and slides as soon as we get that processed. And stay tuned for next time. Thanks again.